Hello and welcome to this video. Let's start with 51. In this video number 11, we have an object on a horizontal surface is subjected to a pulling force F at an angle 30 degrees to the horizontal. When it moves forward at a constant speed for a distance s, the work done by pulling force F on the object is. So which of those expressions represents the work done by this force? This is actually a simple question, because we do know that the work as a formula is the scalar products of force times the displacement. When it is a scalar here in mathematics, we can just like replace it or reformulate it as magnitude of F times the magnitude of the displacement times the cosine of the theta, where the theta is the angle between the force and the displacement. So as its motion here, it's 30 degrees. That means we can do that easily. We have W would be equal to F times the S times the cosine of the theta, which is 30 degrees here. So the B is the correct answer here. It's not the sine here. Okay, the object is pulling or it's moving horizontally, but the force is done with an angle 30 degrees, like in this case here. For the 52 here, we have which of the following statements is true about gravitational potential energy? Gravitational potential energy, which is mgh, I mean. The gravitational potential energy is shared by the object and the Earth. This is correct. Because of what? Because to have a gravitational potential energy, we do need at least two objects. For instance, Earth and a certain other object. So because of the masses of these two objects, there will be an attraction, what causes what we call the gravitational potential energy. Okay, so the magnitude here for B, the magnitude of gravitational potential energy is absolute. It's not absolute, it's relative. It depends on where we did choose our zero level. We can say it's a zero level, like that. So for instance, if the object is under the zero level, that would be something that is negative, but if it's on the top, that would be something which is positive. So it's not absolute, it depends on the reference. For C, we have for an object on the ground, its gravitational potential energy must be zero. This is not all the time correct. Okay, so let's say we do have an object and is near to the a wall, for instance. So while usually actually here we have we do have what we call while set the ground as 0, we don't have actually we don't have to if our reference level is the bottom of a nearby well, for instance. If this is the wall nearby of this is the object here, and if the reference level is a tabletop, for instance, this is the level that is chosen as a reference. So the object here in the bottom or in the ground has what we call a negative energy. It's a minus GPE for this object here because it is under the reference level determined. Okay, so we can say that the C is not correct as well. For the D, the direction of gravitational potential energy is vertical and downward. For the GPE, it's clear that it is something scalar. It's not a vector quantity. It doesn't have a direction. That means the direction doesn't matter for the GPE. What matters is the magnitude of the potential, gravitational potential energy. So we cannot determine, or there is no direction for the gravitational potential energy. It's neither downward or upward or any directed to any other directions. For the 53 here, a satellite is moving in a circular orbit. It's orbiting in a circular shape around the Earth at a constant speed. So this is the Earth and this is the path of the satellite. The speed is constant. The larger the radius of its orbit, the more. So as we increase the orbit of the path, what's gonna happen for the other properties? The higher the line speed. Okay, so let's get back to the formula that's relating between the speed and the radius. Okay, here we have the higher the line speed. This is not actually the correct one. Why? Because here, if we take the speed formula in terms of the radius, it's gonna be square root of gm divided by r square. So as the radius is increasing, it's in the denominator. That means the speed is decreasing. So as the satellite, or as the radius increases, the higher the lower the line speed. So A is not the one. For B, the greater the angular velocity, the same. The omega would be something square root of gm divided by r cubed. So as the r increases, the omega decreases. That means it's not the B as well. The larger the cycle. When we say the cycle, we mean by that the period. It's the time taken to complete one cycle revolution, or one revolution around the center. Okay, so if you take attention to the Kepler's third law, it says that the square of the period or the cycle is proportional to the radius cubed. That means as the radius increases, the period or the cycle is getting larger and larger. So it's the C what we are looking for here. So for D, we have the greater the centripetal acceleration. The greater the centripetal acceleration, this is not actually correct. Because of what? What do we have as an expression of the acceleration? We do have, from the Newton's second law, the acceleration is just like gm divided by r square. The r, again, mathematically is in the bottom, in the denominator. As the r, or as the radius increases, the acceleration will decrease. Finally, we can say that the C is the correct answer for our case here. Let's have a look at the question before the final one. The 54 here, we have if a light ball and a heavy ball are vertically thrown with the same initial velocity, let's denote it as a v0, without air resistance, then what's gonna happen? We have two balls, a heavy one and a light one. They were sent with the same initial velocity or the same speed. At a certain level, they will reach a certain altitude. Maybe the same altitude, maybe a different altitude. We're going to just like analyze the situation here. So, is it A, the heavy ball rises higher? Is it B, the light ball rises higher? Both balls reach the same maximum height, cannot be determined. We actually need to choose only the C. Neither the heavy nor the ball will reach higher altitude compared to the second one. So both of them will reach the maximum or the same maximum height. In kinematics, we do have this formula. At a height, this is the final velocity, the initial velocity, the gravitational attraction, and the height. So at the maximum height, if we denote it as h maximum, the v would be equal to 0. That means the maximum height, they wouldn't have any speed. So the 0 would be v0 squared minus 2gh, which means the h would be here we have v0 divided by 2g's. Okay, so as we can see here, the maximum or the height has no mass in its formula. So the height is independent on how heavy or how light this object is sent upward or even downward, which means the two balls will reach the same range. Finally, for this video, we do have 55 in the process of a uniform circular motion. Which of the following physical quantities remains constant? Which one is constant? Is it the speed, the acceleration, the momentum, or the centripetal force? It's actually gonna be the speed, because speed is only magnitude. It has magnitude, okay? Or magnitude. The acceleration, as acceleration is a vector, which means it has magnitude and direction. So the direction of the centripetal force is always centripetal. That means it's pointing to the center. If the object is at this position, for instance, it's going to point like this. But once it reaches a certain different position, the direction will change. So the acceleration is not remaining the same, or it's not remaining constant. The momentum, the P is mv, as the P is a vector because the velocity is a vector. The velocity again is changing the direction. So the direction is not the same while the object is animated with a circular motion. So the momentum as well is not the same all the time. Centripetal force, Newton's second law says that the F equal ma. As the A changes the direction, so the F does as well. The centripetal force wouldn't be the one that remains constant. So speed is a scalar quantity. It's gonna be the same all the path of this uniform circular motion. That's it for today. See you in the next video. Don't forget to subscribe and put your observations, your questions in the comments if you do have some.